My name is Thibaut de Molenaar, and I'm Global Key Account Manager at ETAP. In this presentation, we'll explore how to ensure accurate, compliance, and collaborative design and manufacturing of your harnesses, while increasing your productivity. Having collaborated for several years with aerospace and railway worldwide leaders, SEE has developed a deep understanding of the issues faced by transportation engineers in the electrical wiring interconnect system design and manufacturing. A vehicle's reliability, safety, eco-efficiency, enhanced comfort, and more services have led to increased requirements for electrical cabling design, manufacturing, and traceability, as well as for the configuration and variance management. SEE Electrical PLM and harness manufacturing is a cutting-edge web-based software suite that is redefining what it means to be efficient in the management of electrical design data throughout the product lifecycle. By integrating advanced product lifecycle management functionalities and configuration management with robust electrical engineering and manufacturing tools, ETAP improves collaboration and ensures regulatory compliance. Based on 22 years of experience with top companies in their industries, our latest version 5 of our software suite, SEE Electrical PLM, is a culmination of the dedication to continuous innovation by our R&D team to introduce new features, enhance existing functionalities, and adapt solutions to the evolving needs of our diverse customer base. The V5 integrates many lessons learned on how to simplify the collaborative design process and provide a more user-friendly interface. But there is more. It also benefits from the best performance, security standard, and scalability available by the latest cloud-based technology. Let us illustrate first together the challenges faced by electrical engineers when they tackle harness design complexity. Imagine, for instance, a high-level requirement received from a customer, such as a read when it's dark, and how we consider this to transform this requirement into the final EWIS deliverable. The system engineers analyze the requirement and translate it into the relevant functions, which would be in this case power source plus switch function plus light function. To fulfill the light function, we may use different equipment devices like matches, a pocket lamp, or even Aladdin's lamp, the all-in-one option for very demanding customers. We then have to define how they are linked to each other, which is done by many wiring diagrams representing the system logical definition. In addition, we need to know the electrical system installation constraints, defining in particular the location of the equipment devices. This is given by the geometry of the harness connecting our 3 equipment devices, which is loaded from a 3D CAD tool. As you imagine, there are many lamps and other equipment in a train or an aircraft, and that means a lot of diagrams. In the same way, a lot of equipment devices, such as the power generator, are shared by different functions. So, to deliver the product quickly and correctly in each product configuration, we have to manage in configuration the system logical definition, its installation, and its equipment devices, and combine them together for a given effectivity. And this makes a huge number of possible configurations that must be managed properly. As it is critical to reduce the number of input data documents generated by the multiplication of the product options and variants, our software suite offers 2 dedicated web applications to manage them properly in configuration, ensure their consistency, and favor their reuse. The first one, SEE Project Manager, a product data management solution, is dedicated to the effectivity and lifecycle management of the 2 main input data: the wiring diagram, which provides the electrical system logical definition, and the harness geometry, which provides the electrical system installation.
Let us have a quick review on SEE Project Manager. So here we are going to manage in configuration the wiring diagram and the geometrical harness. So for instance, if I filter on the harnesses, I can select given item here. Okay, so I can easily create a new solution of this selected item, or a new version or new internal version. I can also change the life cycle of my harness or change the validity. If I want more information by clicking on edit, I can access on the quality check error, for instance, here. Also get a preview of my harness like this. Get information about one connector. In the same way, I can also create a new wiring diagram. So I will draw first in my schematics tools, and from SEE Electrical Expert, I will call SPM to upload my wiring diagram. So here, as you can see, you have the solution number, the version, the internal version, life cycle status, the system, the subsystem, and the validity here.
In addition, the second web application, SEE Device Manager, allows the users to manage in configuration in the same way as the last input data, the equipment devices and connectors. It allows you to assign the right part number to them and to manage also their life cycle, effectivity, and versioning. SEE Device Manager can be browsed from our schematic tool, SEE Electrical Expert, to retrieve the right device naming as well as its connectivity whenever defined via its part number. Because both web applications, SEE Project Manager and SEE Device Manager, are linked to each other, they allow collaborative design among teams from different domains. Since the part numbers of the electrical components used in building the harness are used at all levels of the EWIS design and manufacturing processes, we manage them in a unique centralized repository, SEE Electrical Equipment Database. This database can be browsed from SEE Device Manager to select and assign a part number to a device, but also from our schematics tool, SEE Electrical Expert. It may be also seamlessly integrated into your RP and PLM system.
Let us see now what we can do with the SEE PLM device web application. So I launch it. This application is dedicated to the management and configuration of equipment devices and connectors we can find in a harness. On the left here, you have a breakdown of the equipment devices by category, subcategories. And in the same way, you can also try to navigate and find your connectors by category, subcategories. If I select, for instance, plug here, I'll get all the plugs in my database. So you can see here the name of the connector, its validity, the solution number, the version, lifecycle status, the part number. So if I can arrange all the columns that I want. If I find a specific connector, I can just type its name, for instance, this one. So I can create a new variant. We name it a new solution here. Okay, so you select this new solution, and I want to assign it a new part number different from the one assigned to the solution 1. Click on Edit to access the property card. And here I click on part number and select part number. And I'm going to browse the equipment, electrical equipment library. So I'm trying to find a 24 pins, which form is circular. So system filters the right ones, and I will select this one and assign it to my solution.
From hundreds of wiring diagram and harness geometry, thousands of connectors and wires part numbers, the challenge is now to offer the fastest process to combine all of them, identify and resolve consistency errors, and deliver a complete harness definition dossier to the manufacturing department. Our web application SEE PLM product is dedicated to the creation and lifecycle management of all the products to be designed. Product versioning makes it possible to compare the products at different maturity. Once a product is created, its harnesses can be calculated very quickly, thanks to the power of parallel computing allowed by our pool of web services. The harness calculation reconciles the logical and physical world. For each wire in a wiring diagram, it finds the matching harness in the installation harness network and routes it inside the harness to deduce the wire length. It assigns also part number to each cable based on the wiring diagram requirement if provided. It calculates the end fittings part numbers, the diameter of harness branches, and the harness mass and gravity center.
Let us see now what we can do with the SEE PLM product web application. So if I launch it, I get a list of all existing products, and I can easily create either a new product here, or starting from an existing one, I can create a new version of this product. The idea being actually to get different calculation depending on the design maturity and to keep the history of the different calculation. So here I select my version 3 of my product Pro Demo, and I'm going to launch the calculation of this version. So I launch the calculation, click calculate, and the system will retrieve the last up-to-date released wiring diagram, geometrical harness, and devices, and the system will combine all of them and calculate the corresponding physical harnesses. And you can see that's very fast. And now it's completed. We can also, using this SEE PLM product, go back to the different product versions, and we can compare, for instance, base product here, this version, we can compare it with another one, this one, for instance. And the system will give us a delta between the different products in terms of harnesses and wiring diagram.
To review the harness calculation result for all harnesses or for a specific harness, our dedicated web application SEE PLM Review offers unrivaled assistance to detect any consistency error, identify its root cause, and deduce what input data needs to be modified. When functional diagrams are also provided, SEE PLM Review will check their consistency against the wiring diagrams to make sure their equipotentials match the wire network. With this SEE PLM Review application, it is also easy to analyze the delta for a given product between two of its versions, or for a given harness to compare it to the same harness in another product, or in another version, or to the prior version that was sent to manufacturing. With our latest web application, SEE PLM Report, we can take advantage of the large amount of data we have in our databases and easily deliver reports by using our default templates or by developing customized ones.
The results of my PSN 99. I want the last version of my calculation. I get the result organized by system and subsystem, but I have many entry points actually to review the results, either by device, or here I've got a list of all my devices of my product, with a number of errors, a number of warning. So this is one entry point, but I can also go directly to my harness, for instance. But also I can go directly to the list of errors. So here I've got an exhaustive view of all the errors so classify by harness with their criticity level here, with the message, detailed message, explaining what's wrong. In addition, I've got also the process responsible for the message here, the date of the check, and also which type of objects the message is attached to. Is it a connective device error? Is it a wire group error? Is it harness error? And so on. So I can filter. If I want only the criticity level error, I can easily filter. I can organize my message by harness or by object type. So if I go back to, for instance, my harness, imagine I'm more focused on the GH2, I can get directly here the error. Okay, organize them by criticity error. So here, definitely you've got some issue about the link to the part number database, but also about other routing issue here. I can also use as entry point the devices, for instance. Imagine I've got some doubt about my equipment to P1. I know there are 2 errors, so I can get the list of error here and warning. But I can also locate, because I don't remember exactly what it is in 3D, locate my equipment. Okay, here I've got my equipment, my 3D, which belongs to harness GH1A. Can try, for instance, to generate all the wires starting from my equipment to P1 connector. So I can generate either the schematics of the wires or the schematics of the equipotential, for instance. Okay, so as you can see, it's quite easy to navigate from the 3D to the schematics and vice versa. Here, for instance, I've got all my wires starting from my connector, going to my terminal block, and I have here highlighted in red all the items which are still pending errors. So typically here I can select this one and also get the list of error of this inline connector. So it was a quite quick overview of all the possibilities allowed by CPLM review to help you find out what needs to be corrected.
Once a harness is released by the design office, you can generate its build-to-spec documentation. I'll send it to our next software tool suite, SEE Harness Manufacturing. This software suite has been developed with Safran, a leader in harness manufacturing with more than 7 production sites around the world, and is now in production in many of them. Let us explore now the key points of this solution. The harness received from engineering is loaded and completed by applying automatically the engineering change notes we name ECN, which are rule-based scripts that automate the harness enrichment for manufacturing reasons and ensure traceability of the modification that was applied. Engineering change notes can be created and managed in the SEE ECN Manager web application, either by using one of the default predefined ECN or by developing your own customized ECN. Then the next operation to realize is the harness flattening on the jigboard table. With the SEE Harness Manufacturing build process model, you can then define and choose the best process to produce a harness. This could change from one production site to another one. During the industrialization, you can define the tools and methods you will use. the number of production phases and operations, and the sorting and the generation of the document data. In practice, the method can be chosen from several industrialization methods, such as forming first and second hand, complete first hand, forming first and second hand, or complete first hand, incomplete first hand, forming first and second hand. You can examine these different scenarios to find the best process according to the production sites and the time pressure. Once it has been defined, the remaining process can be a fully automated delivery. A shop order from the ERP will be sent to SHM launcher application, which will trigger the generation by 2 dedicated applications of the right data and document for the harness in the given version. The first application fed by the launcher is the SHM wires prep application, used to create optimized batches for cutting machines and label printers. The second one is the SHM working instruction application, to generate and deliver to each workstation the expected paper or interactive instructions that describe to the operator the step-by-step process to assemble the harness. Finally, the differential models will support you in any change needed during the harness production, pointing out the changes and what rework should be done. Later, our customers can benefit from our troubleshooting and documentation web application, SEE EDWIS. As you can see, by leveraging automation, customization, and integration with the latest cloud-based technology, SEE Electrical PLM empowers your electrical engineers with powerful tools that transform the way EWIS is designed, while SEE harness manufacturing brings process improvements, paperless work instructions, and a full digital traceability. Thank you for attending our SEE Electrical PLM and SEE harness manufacturing presentation. We showed you how to ensure accurate, compliance, and collaborative design and manufacturing of your harnesses while increasing your productivity.